All right, so homework check was very good. Very, very good. Glad we're doing the homework. Again, I'm going to come around like Judge Judy on Monday to check today's stuff. I did. For a little bit, yeah. I can't see without them though. Do you have a question? Okay. We're going to stick to this. Okay. Yesterday we learned two exponent laws, the multiplication law and the division law. Yes? When we multiply two exponents with the exact same base, we just add the exponents. Not so bad. And when we divide two powers with the exact same base, we could just subtract the exponents. And we did that over and over and over, again and again and again, and I got really good at it. Now today, it's a little bit different because what we're doing here is we're learning new exponent laws, and two, when we get to the boards, we're going to be combining the old exponent laws from yesterday and the new exponent laws from today. We're going to be able to simplify some pretty cool stuff. So this exponent law number 3 is called the power of a product law. So product means multiplication. So for example, we have the power of the exponent 3 here, and this is the base would be 5 times 2. So that's what we call the power of a product law. Now remember, like in exponent laws, very rarely do we use that little x for multiplying. Sometimes you might see a dot, and sometimes you might not see anything at all, and we just know that that means multiply. So if we have 5 times 2 to the exponent 3, and we were to do this the long way, right? We're trying to do this the long way, and we have to expand this. What we're going to have is 5 times 2 multiplied by itself 3 times. So it'll look something like that. So go ahead and write that down. So because this is all multiplying by one another, right? 5 times 2 times 5 times 2 times 5 times 2, we don't really need the brackets. So in the next line here, we're just going to drop the brackets, which seems, right now, it seems like, why are we doing this? I know. So if you notice, we literally have the exact same thing as the line above, just without any brackets, because they're not really necessary. They're nice to use there to see that we're multiplying 5 times 2 by itself 3 times, but really they don't need to be there. Now in this next line, what we're going to do is we're going to kind of group up all the 5s, group up all the 2s, because it doesn't really matter the way in which you multiply, right? Because of that thing called the commutative property. So instead of having 5 times 2 times 5 times 2 times 5 times 2, that's the same thing as saying 5 times 5 times 5 times 2 times 2 times 2. And if we were to kind of simplify this and express it as, well, single powers, we would have 5 to the exponent 3 times 2 to the exponent 3. Now that's an awful lot of work to do something very simple, I feel like. Because if we had the beginning question here, 5 times 2 to the exponent 3, what's a great way that we can go from this beginning question right to the very end? Yeah, Jonah. We're going to add that exponent 3 to the 5, and also, yeah, so this 3 is essentially going to the 5 and to the 2. So when we write down this exponent law, like the law here, we have two things like x and y. They're multiplying by one another, and they're both in brackets to the same exponent a. So this exponent a, like we just talked about, is going to go to the x, and it's also going to go to the y. And really, what goes on in my brain when I see a question like this is it kind of goes like this. Well, what's that? No notification. It's just literally like that. That's what happens. Now, that's great and everything. Maybe we could try an example or two. So here we have xy to the exponent 4. So to get rid of the brackets, what's this going to simplify to here, Jonah? Perfect. That's awesome. Thanks. Now, how about B? We got not two things in the bracket, but we got three things in the bracket, and they're all multiplying by one another. So how might this simplify? Yeah, Jonah. Yeah, so maybe we'll keep the same order. Yeah, every single base in here is going to receive that exponent. So we'll get 3 to the 4, then times p to the 4, times q to the 4. Now, can we simplify 3 to the exponent 4 one more step further? What is 3 to the exponent 4? 81. Nice. Yeah. I mean, sure, you just use a calculator, or you can find that mental math trick from the other day. Yeah, we'll get 81 p to the 4, q to the 4. Any questions about that law? It's a good law. Great law. My favorite? I don't know. Still good, though. Now, we kind of have a similar law, but it's called the power of a quotient. Yeah? It's not power of a product, meaning multiply. It's power of a quotient. And what that is going to look like, a quotient, like this right here is a quotient. This 2 over 3. Quotient meaning like dividing. Now, this is where we can kind of pull out all that stuff we did near the beginning of this course with multiplying fractions. Now, if we're going to expand 2 over 3 to the exponent 4, how many times are we multiplying 2/3 by itself? 4 times. So it's going to be 2/3 times 2/3 times 2/3 times 2/3. Absolutely. Now, back then, beginning of this course, we now know that multiplying fractions requires numerator times numerator, and then denominator times denominator, which is totally right. In fact, in this particular scenario, we're going to go numerator times numerator times numerator times numerator, right? We're just going to multiply all the numerators together, likewise all the denominators as well. 3 times 3 times 3 times 3. So when we write that out, it might look like that. Okay? Multiplying all the numerators together, and then all of the denominators together. And if we were to now simplify this so that the top is a single power and the bottom is a single power, we would have something like 2 to the exponent 4 over 3 to the exponent 4. Now, if we started at the very beginning here, 2/3 to the exponent 4, and we went all the way to the end here, what's the biggest shortcut here? Like, what do you see? What's the quickest way? Yeah, Charlie, what do you think? Yeah, Charlie's saying that each number in the bracket, very similar to the previous law, each number in the bracket will receive the exponent. So this exponent 4 goes to the 2, and it also will go to the 3. And it kind of avoids us doing all of this work. So now that we've done all the work, we can appreciate the shortcuts. And maybe we should jot down the law. So the law here, we have a number divided by a number. Basically, if we have a quotient, and it's raised all to the same exponent of a, what's going to happen is that that exponent will go to the top number and the bottom number. And again, what goes on in my brain is that when I look at this a outside of the bracket, staring at it, my brain automatically just does this. It just knows to do that. Like, that's how fast you're going to get at these. Okay, we're going to do an example. Oh, kind of a nasty example, right? Because if we take a giant leap back to maybe the first couple weeks of this course, we know that when we square a negative number, right, a negative number in brackets, the outcome should be positive, right? So we're multiplying a negative by itself, we should get a positive outcome. But according to these exponent laws, we're saying that this exponent 2 is going to go to the top and the bottom. So it's going to go to the negative 3, and then it's going to go to the positive 4. So it should look something like that. Now, see how the negative 3 is within the brackets? It's inside of the brackets. So we should treat that negative 3 as also a negative 3, you know? Not negative 3 squared, but negative 3 squared. Yeah. No, not for the negative 3, because we are going to square the negative here. You see how the negative is inside of the brackets here, Jonah? So because that negative is inside of the brackets, it's also going to be getting squared with the 3. Well, it's situational. There are times where the negative is outside of the brackets, in which case we wouldn't touch it. But in this case, it's on the inside of the brackets, so we have to work with it. So we could leave it like that, but we can go one step further to simplify. So negative 3 squared ends up being positive 9 over 4 squared, which is 16. Not bad. Any questions about this law? Okay. Now, usually when I teach this, or when I taught similar lessons to this last year in the 9 academic course, we would do the first 4 laws in the first day, and everything would be great. You know, just very similar to you folks. Like day 1 went awesome, and this fifth exponent law, is where sometimes it got a little weird. So when you see this fifth exponent law, this is where you kind of got to be on high alert, because it's a little tricky sometimes. How about this? We have 3 squared. Yeah. What does that even mean? 3 to the power of 2 to the power of 4. Isn't that weird? It's a weird problem. Yeah, Jonah, what's up? Well, it's 3 squared to the power of 4. Okay, I see what you mean. But my brain likes to work from kind of the outside in a little bit sometimes. So like, well, what I'm thinking is, how many times are we going to multiply 3 squared by itself? No. How many times are we multiplying 3 squared by itself? 4 times. So we're going to get 3 squared times 3 squared times 3 squared times 3 squared. Yes? Essentially, but we're just going to simplify here. I'll show you what I mean. Now, each of these 3 squareds can be further broken down into 3 times 3, right? So really what we should have is 3 times 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 3. So essentially, it's like the first 2 here, this is 3 squared times 3 squared times 3 squared times 3 squared. And how many 3's do we have here? Is there 8? Yeah. So we could rewrite this as a single power as 3 to the exponent 8. So now, have a look. What's the shortcut here to go from the very beginning, 3 to the power of 2 to the power of 4, to the very end here? Yeah, what do you think, Charlie? Multiply the exponents, right? So here's the law. If we have some x to the raised to some exponent a, and all of that is to another exponent b, then what we're going to do is then multiply those exponents. Be something like that, a times b. Okay. Question? Oh, stretch? A stretch? Okay. How might we be able to kind of simplify this? 4 to the exponent 3 to the exponent 5. Slow down a minute. Slow down. First of all, sorry, we'll slow down here. 4 to the exponent 3 to the exponent 5. Jonah, what do you think? 4 to the exponent 15. Absolutely, because we're going to multiply those exponents. Yeah.
I'm wondering how like that makes sense because the elements of the stuff that is outside of the bracket.
Well, Dylan has a great point. Dylan says, well, Shouldn't we be doing 4 to the exponent 3 first? Because bedmass says brackets and then do it to the power 5. Now, what happens when we're in this situation? What is x to the exponent 4? It's like we don't know. We really don't know. Right? So then it's like, okay, well, if we're going to simplify this, really, this is going to be equivalent to x to the power of what? 32. Because 8 times 4, or rather 4 times 8, is 32. No, the exponent is 32. The x remains the base of x. Well, sometimes there could be a question where it's like, okay, well, evaluate this exponent, or this power here, when x is negative 4. And then you go to your simplified version and plug in negative 4. Because to work with something that's simplified, it's a lot better to work with something that is not. Okay, how about this one? Whoa. Jonah, yeah? Yeah. Yes, and I love that you said that. So Jonas, if you didn't hear it, Jonas said bracket negative 3 in brackets to the power of 14. And that's perfect. That negative 3 has to stay in brackets because it was in brackets originally. It's not just the 3 that's getting all these exponents, it's also the negative as well. Pardon me? Oh, these are square brackets. The reason why I chose to use square brackets for the outside here is because sometimes when you see round brackets on the inside and then more round brackets, it's hard to distinguish between the brackets. But when one is round and one is square, it's very simply seen as, okay, we got negative 3 in here, squared, and all of that is to the exponent 7. It's more for aesthetics, more to just see things a little bit easier, so it's easier on your eyes. If we had a whole bunch of round brackets here, I'll write it on the board, it would look like this, and I don't know how you feel about this. Like that kind of looks a little strange, doesn't it? So I decided, I'm like, well, maybe we'll just stick with square and round. Yeah? And it's not the first time we've seen that before. Even in those kind of large bed mass questions, we had multiple brackets to work within. Remember we called them nested brackets? So sometimes we had to work with them as well, and we always know to go from the inside out. Okay. So folks, that is pretty much the lesson. What I would like us to do is to get into some groups, and there's a total of 10 questions here, and they're very fast. They're shockingly quick. So what's going to happen is, I know there's going to be a ton of us that rip through these questions super duper fast. So in the case that you do that, I have some tougher questions that involve combining exponent laws. Now, we're not going to start here. Like I said, we're going to start with this piece of paper at the boards, and then eventually we can move into questions like these ones here, which are kind of tough, if I'm being honest. And then if those ones go real fast, I got a couple more here that, again, are extremely tough. Check them out. Oh, yeah, and these ones too. Like, are we going, like, this would be like on a CYU, it would be like part D, you know, like these could be fairly tough, especially B. I mean, A and C, I suppose, could be like a part C type of question, but like this B here would be like a part D for how like tough that one is. Okay, so let's back up here. We got that last law right there. Okay, so let's get a head count here. How many people we got in here?